All right, so here's 5.6, geometric sequences. We have dealt before in a previous unit with arithmetic sequences. And if you forgot about it, go back to my videos and watch it. There is another thing. I'm going to put a little star right here as a note. As a note, go watch the arithmetic sequences video. Okay, arithmetic sequences video. So you can see how different it is, the arithmetic to the geometric. Okay, they're different. And sometimes here they'll be mixed and you need to be able to tell the difference. First, I'm just going to introduce you what is geometric sequence. And then later you should go ahead and watch the arithmetic sequence video so you can kind of like be able to tell them the difference. You will be asked both of them on the test to tell the difference. So, and a lot of the students forgot about the arithmetic sequences. This is geometric. So, geometric sequence has a common, there's one specific thing about geometric sequence. It has a common ratio. Not a common difference. A common difference is for this guy up here, okay? It has a common difference. Okay? So in arithmetic sequence, we have a common difference. One term in the sequence to the other, and so forth, following to the other, has a common difference between them. And in here, in a geometric sequence, there's a common ratio. To find this common ratio, you always divide one term by the previous. So divide one term by the previous term. Okay, and that is how you find that common ratio. Students keep trying to move forward, and I told them you can't, because you have to divide one term by the previous one to find that ratio. We want a ratio, and in parentheses, it is a fraction. Okay, a ratio is a fraction. Sometimes that fraction happens to be a whole number, like a 2. But you can say, Ms. Myers, 2 is not a fraction. Sure it is. It can be written as a ratio. I can write 2 as 2 over 1. So a ratio sometimes will be a nice fraction, visible fraction. Sometimes will be a whole number. But every whole number can be written as a ratio. Okay? The important thing is to divide one term by the previous term. Put that in your mind so you always find the correct ratio. Okay? All right, now let's take a look at the formulas. If you give me a sequence, a geometric sequence, and you want me to write the explicit or the recursive formula, the students get a little bit freaked out seeing this, but this is the same thing as if I had written f of x. Okay, we plug in x for the domain, we get a y value. Well, this is the same thing. A of n, okay, so if some people like to put a little parenthesis, that's okay with me. This guy over here is my first term, okay, the very first term of the sequence. So let me scribble this out. I was just trying to explain to you what a of n means, okay, a sub n. This a sub 1, or a of 1, is our first term of the sequence. Every sequence has the very first term. That's my very first term of the sequence. This r over here is our ratio, okay, and we know how to find the ratio. We divide one term by the previous. And this over here is our is just our exponent, and it usually has to do with trying to find the other terms in the sequences, okay, in the sequence. So that is the explicit formula. Then we have the recursive formula. And the recursive formula, we have a of n, like if it was f of x, is just a function, equals, we have the ratio, and here is a previous term, okay, times the a of n minus 1. So this is the previous term. So I can always find one term if I know the ratio, if you give me the ratio and you give me a previous term, okay? So these are kind of complicated. We go a lot more in depth in math 3 and in the statistics we use that. So we always replace here the first term in this equation, in this explicit formula, and we always replace the ratio. Everything else stays the same. So what I put in red here, first term ratio and ratio, is what we replace. Everything else we leave the same. All right? Okay, so let's go ahead and do some practice here. So they're asking here on your worksheet 5.6, determine whether the sequence is geometric sequence and explain. All right, so I'm going to do number 1 and I'm going to do number 3 so I can explain it to you. Number 1, they gave me 1, 4, 16, and 64. Let me write a little bit bigger. 1, 4, 16, and 64. Those are the numbers they gave me. So I want to know if it's geometric. Then I'm going to divide one term by the previous. I always have to start with the second because the second term has something in front of it. Okay? So I'm going to divide, it's a division. So I'm dividing 4 divided by 1, we get a 4. That is a ratio. Now I'm going to go 16 divided by 4. It's a division. 16 divided by 4, the answer is a 4. Okay, so there's my ratio. 4 over 1, okay, 4 over 1 is a ratio. Now I'll do it again. 64 divided by 16, 64 divided by 16, the answer is a 4. So see, I get the same answer every single time. 4 over 1, 4 over 1, 4 over 1. This is my ratio. Okay? So is this determine whether the sequence is geometric? Yes. The ratio equals 4. Okay, every time I divide, 4 divided by 1 is 4. 16 divided by 4 is 4. 64 divided by 16 is 4. So we do get the same ratio. Now let's take a look at number 3. Number 3, I have 5, 15, 25, and 40. Okay, so let's determine here. 15 divided by 5. I'm going to write it down. 15 divided by 5. And when you do this division, you get a 3. Okay? 25 divided by 5. 25 divided by 15, sorry. 25 divided by 15. Now, if you don't know how to reduce it, and you're having a hard time reducing this, you can always use the calculator. So if you divide 25 divided by 15, you will get 1.6. So 1.6 if you do it in your calculator. If you do it by just reducing fraction, you should divide by 5 top and bottom, and you'll get 5/3. So he gave me 1/6. Already failed. Okay. If you want to do it one more time, 40 divided by 25. And you can go in your calculator and you can do it. 40 divided by 25. And you get 1.6. But that is not the same ratio, is it? So they're different. 3, 1/6, 1.6, they're not the same ratio. So it failed already. It is not geometric. Okay, so I'd say not geometric, not common, no common, right? No common ratio. That would be my explanation. Okay, no common ratio. All right, so that is how you decide if there's a common ratio or not, if it is geometric or not. Now, here it says find the common ratio for each geometric sequence. It is exactly the same thing we were doing up here to decide to see if it's geometric or not. Okay, so I would divide 8 divided by 2, you get a 4. 32 divided by 8, you get a 4. Check 128 divided by 32, you should get a 4. So you can find that common ratio, the ratio would be a 4. Okay, so you got to do it the same for all of them. Number 6, if I divide 150 by 15, what do we get? 1,500 divided by 150, what do we get? Keep doing that. 150 divided by 15, you should get a 10. And then you keep going and you keep going. So you can find that ratio. That's what they want you to look for here. Okay? Now, write the explicit formula for each geometric sequence. For me to write the explicit formula, I just need 2 pieces of information. Let me go ahead and do number 9 for you. Okay? Number 9 says, I have the number 3, 6, 12, and 24. And they want me to write the explicit formula. Okay, that's what they want me to write. So let me go ahead and put the paper up here. So the first thing is the explicit formula. The explicit formula says A of n equals the very first term times the ratio to the n minus 1 power. So first, I need my very, very first term. Let me grab a pencil here. So I would like to label them carefully. This is my first term, as the first number I see on the sequence. This is my second term, this is my third term, and this is my fourth term. And if I wanted to keep going, I can even find out what is my 10th term, okay? This formula is going to help me find that. So, now I know what my first term is. I can replace that in my formula. So my formula is going to be a of n equals the number 3 times, I don't know the ratio, but I know I'm going to take it to the n minus 1 power. I just need to figure out the ratio. Okay, that's what we're missing. We know that a of 1, the very first term, is a 3, but what is the ratio? So the ratio, we divided one term by the previous, is a division. So I would do 6 divided by 3, it gives us a 2. Okay, now 12 divided by 6. 12 divided by 6 gives us a 2. And I do 24 divided by 12. 24 divided by 12. That also gives me a 2. So it worked for every single term. My ratio is a 2. So now I can go over here and write the number 2 in parentheses, and it works. If they ask me to find what is the 5th term, we don't know what the 5th term is, right? I can guarantee you we can find out easily the 5th term. I can plug in a 5 for the exponent here and find that out. If I want to find the 5th term, a 5th, a sub 5, then I'm going to have 3 times 2 to the 5, wherever there was an n, 5 minus 1. And I can do that in my calculator, okay? So a 5th, the 5th term in my sequence, is going to be 3 times 2, 5 minus 1 is 4. And you can do that in your calculator. 2 to the 4th power. If you're having a hard time figuring out what is 2 to the 4th power, you don't have to panic. You can go ahead and use the calculator. 2 to the 4th power is 16. Okay, so 3 times 16. And 3 times 16 is 48. So my a 5th term is 48. All right? So does it really work if I put a 48 here? Is 48 divided by 24 is still the ratio of 2? Yes, it works. Okay? So I'm sorry I went further explaining. They really don't want you to go any further. They were just asking for this right here. Okay? They were just asking for the equation. But I'm explaining how does the sequence works, how sequences work. Okay? They give me a sequence. It follows a nice pattern and is a division by 2, or and then once we find that ratio, we can go ahead and put it in here, and we can find any term we want. I could ask you what would be the 100 term of this sequence. So, and that was number 9. All they were asking is write the explicit formula for each geometric sequence. So this would be a of n equals, my first term was 3, the ratio was a 2 to the n minus 1 power. Okay, that is our equation, our function, our explicit formula. All right, now they're asking us write the recursive formula. Okay, right here on the bottom, write the recursive formula. So let me use this piece of paper here. Let's do number 13. All right, so number 13, it has 1, 7, 49, 343. The recursive formula, let's write that down. And these formulas will be given to you, so you don't have to stress out about memorizing them. So the recursive formula says a of n, you can find any term you want as long as you know the ratio and you know the previous term, the a of n minus 1. Okay, so that's what they want us to write. The only thing we replace the ratio. Okay, that's the only thing we really need to replace is the ratio. So let's find out the ratio. I don't need the first term, I just need to figure out the ratio. So to find out the ratio, we divide the one term by the previous, is a division. Okay, let me put my little arrow, is always a 49 divided by 7, is always a division. So 7 divided by 1 is just 7. And 49 divided by 7 is just 7. And 343 divided by 49, you will get a 7. So when you do the division, all you get that the ratio is a 7. And that is all you need to write your formula. That's the only thing you replace in the formula is the ratio. So A of n equals 7 times any previous term. Okay, A of n minus 1. So if I want to find out what my next term will be, then I just have to multiply it times 7. I would get the next one. And then you can keep finding the next one, and the next one, and the next one. Okay? So that is how you find, that's how you use the recursive formula. The only way I can, unfortunately with the recursive formula, I cannot find terms that are far in advance. I can only find the next one and the next one. Okay? So that's how I would find the next term. And that is our recursive formula. All right, so, and that was number 13. A of n equals 7 times the previous term. So I can find out what comes next if I use 343. And then I can find out what comes the following after that if I use that number. So you can always find the next one. Okay? So you should be able to do this worksheet. It is repetitive here in the back. It asks you to determine which sequence is geometric, find the common ratio, write the explicit and the recursive formula. Okay? So it is the same thing as we're doing in the front. Identify each sequence as arithmetic or geometric or neither. Okay? I'm going to do one of those to make sure you understand it. Okay, for geometric, I check division from one term to the previous. Arithmetic, I check addition or subtraction moving forward. So arithmetic is addition or subtraction, and we move forward. Geometric, we are doing a division, and we're always working on the previous term. Okay, so try to remember that. I'm going to try for arithmetic first. If it fails, then I switch it to check it to see if it's geometric. How do I go from 1 to a 6? Let me write those numbers bigger because I am losing my sight. 1, 6, 11, 16. This is the first question right here. It is number 21. Okay? 1, 6, 11, 16. I'm going to check to see if it's arithmetic. If I add, what do I add to get to 6 or subtract, right? From 1 to 6, I add a 5. Okay? If I add 5 again, do I get a 11? Yep. If I add 5, I get a 11. If I add a 5 again, do I get 16? Yep, I do get 16. So it is a arithmetic. The addition, the common difference between the terms is a 5. If you go 6 minus 1, you get a 5. If you do 11 minus 6, you get a 5. If you do 16 minus 11, you get a 5. Even working backwards with adding or subtracting, you get a common difference. So the common difference is 5. Therefore, this number 21 is arithmetic, not geometric. You already passed the test for arithmetic, therefore it's arithmetic. Okay? Now let's check number 23. Let's check number 23. Let me find a blank piece of paper here. Here we go. Let's check number 23. 1, 5, 10, 16. Love it. Let's check it. All right. So let's check for arithmetic first because it's the easy way to check. From 1 to a 5, all I have to do is add 4. 5 minus 1 is 4. From 5 to a 10, I would have to add a 5. 10 minus 5 is 5. You already failed, okay? So you already failed arithmetic. I'm not adding something at the same pattern, the same value. 16 minus 10 is 6. So from 10 to a 16 is a 6. So as you can see, it's not arithmetic. So not arithmetic. Well, let's check to see if it's geometric. Okay, so failed, this one failed. It's not arithmetic. Let's check for geometric. 5 for geometric. Geometric, we are dividing. Okay, 5 divided by 1. If I divide 5 by 1, I get a 5. 10 divided by 5, we get a 2. You already failed. You don't even have to go any further. You already failed. It is not arithmetic and it is not geometric. Okay, it is neither. So, neither. And that's how you work on this arithmetics and geometrics. You check to see if you're adding or subtracting for arithmetic. You check to see if you're dividing, and we always divide it backwards. It helps it that way. Even when we're adding and subtracting, we check it backwards as well. It works, okay? So, I would like to do the other two to see if you find out how you go from one to the other. Use your calculator, especially here with decimal values, okay? So, there's word problems over here. They give you the equation. A certain population of finches, I don't even know what that is decreasing by 6% every year. The current number of finches, I hope I'm saying this right, in the population is 456. So I have a certain number of this thing here. I have no clue what that is. I should have checked that before, huh? Curiosity. So I have an initial amount of this thing, and it keeps on decreasing. I have a decay case here. So I know I have a decay, and I am going to go ahead and already pay attention to the kind of formula I'm going to be using it. If I am dealing with, they actually want us to write the explicit and recursive formula for the geometric sequence formed by the decrease in the number of finches. Okay, so they want us to write two formulas. We have the initial amount. We have 456. So we have that A1 is 456. We have the decreasing rate here. We have the decay rate. So if I do 1 minus the decay rate, which is 6%, we have to change the 6% into decimal. Okay, so 6% in decimal is 0.06. Right? So if you do that in your calculator, don't even try to guess it, because a lot of the students sometimes make a mistake when they try to change something into decimal and then subtract it in their minds. Don't try to do that in your mind. Do it in your calculator. When you subtract 1 minus 0.06, you get 0.94. That's what you get in your calculator. Do it carefully. So I know that my rate is 0.94. Now I just need to write the recursive formula and the explicit formula. I have all the information I need. I have the decay rate and I have the initial value. So you can write the formula having those two pieces of information. Okay? So you can write the explicit, A of n equals my very first term, 456, times the ratio, which is 0.94, to the power of n minus 1. And then they want the recursive. The recursive is A of n equals, all I need is the ratio. I'm going to put in parentheses 0.94 times the A of n minus 1. So there you go. All right, you just had to pay attention to this little information over here, which was the decay. If it was growth, I would have written 1 plus 0.06, okay? Because growth, you get 100% of what you started with, plus whatever rate you're increasing. Since it's decay, you're going to get something smaller and smaller each time, okay? That's why you get 0.94 of the initial value of 456, okay? So that is what it should help you, okay? All these examples should help you finish all this worksheet and study for the test, okay? Good luck.